All right, guys, so we're going to solve trig equations. If you wonder why yesterday we did the inverses, it was for today. So we're going to solve equation with trigonometric functions in them, and here we go. All right, the first one says solve 2 cosine x equals -1. So what we're going to do every time we do one of these is we're going to isolate the trig function, the cosine x. So I'm going to divide both sides by 2 and make it 1/2. Once you get there, it's basically asking you, okay, where's cosine -1/2? Well, those are the ones you should know. Cosine is -1/2 at power 3 in quadrant 2, which is 2 power 3. Also in quadrant 3, which is 4 power 3. And sometimes that's all the answers we're going to put, but if it doesn't give you restrictions on where you want your answers to be, you have to give everywhere where it's 2 power 3 and 4 power 3. So we're going to add 2n pi, or your book I may use 2k pi actually, but one or the other, 2n pi, 2k pi to represent where k is an integer, where k represents all the possible values. You know, if you go around the circle, it's 2 pi, so all the possible values, not just in the between 0 and 2 pi. All right, try another one. 4 sine squared x equals 1. I'm going to divide both sides by 4, which gives me 1/4. Now that says sine squared. To get rid of the square, I'm going to take the square root of each side. The square root of sine squared is sine x, the square root of 1/4. Don't forget, when you take a square root inside an equation, you got to put a plus or minus in the front of 1/2. So this is asking you where is sine either positive half or negative half. Well, that's all 4 quadrants because sine is, you know, positive or negative everywhere. So sine is 1/2 at the power 6s. So I'm going to put power 6, 5 power 6, that's quadrant 2, 7 power 6, that's quadrant 3, 11 power 6, that's quadrant 4. And again, at the 2n pi, because that takes care of every single value, no matter how many times you go around the circle. My n and pi got combined right there. There you go, a little bit. But so the work's not that hard. You do have to remember your trig values and then realize you got to put 2n pi after your answers if it doesn't give you a restriction, which you're going to see in a second. Like here, that's a quick second. So there's a restriction. This is what I like to do. I think this will be easier for you because it's going to give you, you don't have to worry about the 2n pi stuff or anything. It just says like solve over that interval. So I'm going to do it the same way. I'm going to divide both sides by 3. So I get tangent of 2x equals -1. So I can't divide by the 2 because that 2 is actually with the x. So it's really tangent 2 times x equals -1. So I got to think, where's tangent -1? Well, tangent's -1 at the power 4 is where it would be -1. So that would be at 3 power 4, quadrant 2, and also 7 power 4, quadrant 1. I'm sorry, quadrant 4. Now, even though I wrote x equals, I should have put 2x equals because that's what 2x equals. 2x equals 3 power 4 and 2x equals 7 power 4. So what I'm going to do to finish that up is just divide both of those by 2 and get 3 pi over 8 and also 7 pi over 8. So when you have the 2 right in front of the x right there, that's kind of how you have to roll with it. You kind of got to divide at the end. So let's continue. All right, this one says solve with the assistance of a calculator, and you're going to need it for sure. So I'm going to start the same things the same way. I'm going to move things over. So I'm going to move the 1 over first, which will leave me a 1/2 over here, cosine x. And if I move the 1 over, I just get 0.2108. To get rid of the 1/2, I'm going to multiply both sides by 2. When I do that, that cancels, so I get cosine x equals 0.4216. And that's not a value that we know. That's why I said you got to use your calculator to kind of see what it is. So I'm going to go with degrees this time. So I'm going to look at my mode. I'm in degrees. So I'm going to say second cosine is the inverse cosine because I'm looking for the angle, 0.4216. And I get 60, that's around nearest degrees, 65 degrees or 65.1 degrees. Now, that's quadrant 1, which is fine. Cosine is positive in quadrant 1. It's also positive in quadrant 4. So what I need is I also need the 65-degree angle that's in quadrant 4. To do that, I would just do 360 minus the 65, which would give me 295. So those are my 2 answers right there. And that one didn't say 0 to 2 pi, but I kind of did that 0 to 360. Hope that makes some sense to you. Again, the work's not bad, especially when you get to use your calculator to punch in the what the value is. So just move everything over except the trig function and then solve away. All right, 2 more and we're done. Sine squared minus sine x equals 0. And again, it's giving me this restriction, which is really good. So I'm going to, first of all, because they're both sines, I'm going to factor out the sine, factor out the GCF. They both have sines, so I got sine x, then I have sine x minus 1 when I factor it. That's all you can do, so just set each factor equal to 0. So I'm going to take, there's one of them, so either sine x equals 0, or to make this right here equal 0, I'm just going to say sine x would equal 1, just like we did when we did equations earlier. So it's asking me, where is sine 0? Well, sine is 0 at 0 and pi on the x-axis. Where is sine 1? Sine is 1 at pi over 2, because it's the y, and that's where y is positive 1. And that's all there is to it. All right, so don't let just because there's a factoring in there mess you up. It's the same stuff. One more. All right, one more factoring here, and it's got two different trig functions. It's the first time we've seen one of those. So what I'm going to do first before I factor it, one thing not to do. I need to say this out loud. One thing not to do ever is divide by trig function. If you divide both sides by tangent right there, it will cancel on one side, on both sides, but you're going to lose one of your solutions, so you don't want to do that. What you want to do instead is move that tangent over here to the left-hand side, along with the other trig functions. And the reason you do that is because now you can factor it out. So if you factor out tangent here, if you factor out the tangent from both terms, that will leave you with 2 cosines squared in the first term and a minus 1 in the second term. So now it's factored, which means either tangent x equals 0, or I have this situation here where I have basically cosine squared is 1/2. All right, now I know where tangent's 0. Tangent is sine over cosine, remember? So anywhere cosine is 0, tangent is, anywhere sine is 0, tangent is 0, and sine is 0 at 0 and pi. So that's 2 of my answers already. Now this side I'm going to have to solve this out a little bit. I'm going to take the square root of both sides. And if I do that, I get square root of 2 over 2. Well, let's just do this. If I have square root of 1/2, it looks like that. Square root of 1 is 1 over square root of 2. And if I rationalize that, it becomes square root of 2 over 2. And because it's plus or minus, it's all the pi over 4. So I'm going to go pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. All right, and that's it. I hope that was kind of okay today. We'll obviously do what we always do and work it out in class tomorrow. And you're going to get it. You're going to be fine. And I will see you then.